Good evening to all. In this lecture, we are going to discuss about polyethylene terephthalate, polycarbonate, polyamide, acrylobutastyrene rubber, polyimide, polyamidimide, polypropylene oxide, polypropylene sulfide, thermoplastic polymers. Polyethylene terephthalate, it is called as PET. It is also called as polyesters. Everyone is familiar with polyester clothing. So polyesters is one of the most popular commercial polymers marketed under the trade name Terephthalate. The microstructure of polyesters is CO, benzene ring C, double bond O and O, CH, CHH, O. This is a monomer, and n times of this monomer ethylene terephthalate will give polyethylene terephthalate. Polyethylene terephthalate, it is used for a long time as conventional polyesters. Conventional polyesters were not of much industrial importance, mainly because of their low melting points. The introduction of aromatic rings into the polyester chain improves the melting point of polyesters. Polyethylene terephthalate is made from ethylene glycol and terephthalic acid. Terephthalic acid is converted into dimethyl ester. This is then allowed to react with glycol to form ethylene terephthalate. Properties of polyethylene terephthalate: it is highly crystalline and it retains good mechanical properties at temperatures of up to 150 to 175 degrees Celsius. It has higher melting point of around 265 degrees Celsius, whereas other polymers don't have such a very high melting point temperatures. The stiffness of PET is comparable to other polymers. One of the toughest of plastic films, polyethylene terephthalate has excellent fatigue and tear strength. It provides resistance to humidity, acids, oils, solvents and greases. Applications of polyethylene terephthalate are polyesters. It is used to make textile fibers. Garments made from polyester fibers have no wrinkles. PET is made into films which are used in the manufacture of magnetic recording tapes, photo films, etc. PET has been made in the development of blown bottles for soft drink use. PET is currently popular as a tire cord. The next polymer is polycarbonates. Polycarbonates is characterized by OCOO group. So see the microstructure of polyesters: O, benzene ring C, CH3, CH3, benzene ring C, C, double bond O. It's a monomer carbonate, and n times of this carbonate will give polycarbonate. Polycarbonate polymer is prepared by condensing diphenoxymethylene derivatives with diphenyl carbonate. Properties of polycarbonates: polycarbonates are highly crystalline, hence it retains good mechanical and electrical properties. Polycarbonates have higher melting point of around 265 degrees Celsius. Polycarbonates have unusual impact strength, so it has been used to make helmets and other television components. Polycarbonates are dimensionally stable and good chemical resistance. Polycarbonates have good thermal and oxidizing stability. Polycarbonates have low moisture absorption, good heat resistance, and its resistance to water and many organic compounds. Applications of polycarbonates: it is used to make telephone parts, machine housing, automobile tail light lenses, unbreakable glassing applications. It is used to make safety goggles and safety shields. It is used to make optical lenses, light globes, base for photographic films. The next polymer is polyamides. It is given by the symbol PA. It is also called as nylons. There are two types of nylons. Nylons obtained from dibasic acids are represented by two numbers. For example, 6,6 or 610. Nylons obtained from amino acids are represented by single number. Nylon example 6. The structure is NH, CHH, NH, C double bond O, benzene ring C double bond O. It is amide. N times of this amide give polyamides. Polyamides are prepared by condensation polymerization between dicarbolic acid and diamines. In nylon 6,6, first digit represents the number of carbon atoms in the diamine, second digit represents the number of carbon atoms in the dicarbolic acid. Nylons are used as both as plastics and fibers. Properties of polyamides and nylon. Nylons possess high strength, elasticity, toughness and abrasion resistance. Mechanical properties of nylon are maintained up to 150 degrees Celsius. Nylon possesses good toughness and flexibility. It offers resistance to many solvents and moisture. It is degraded by strong acids. It has low specific gravity. It possesses good toughness and flexibility. Applications of polyamides nylon as fibers. About 60% of nylon fibers are used as carpets. 20% of nylon fibers are used as apparels. About 20% of nylon fibers are used as tire cord. Applications of polyamides nylon plastics. Nylon plastics are used as a substitute for metal in bearings, gears and cams and so on because it possesses greater strength. Electrical wires are insulated with nylon which provides outer cover to protect primary electrical insulation. Nylon plastics is used to make rollers, slides and door latches. Nylon plastics is used to make bearings and thread guides in textile machinery which requires no lubricant that could damage yarn or cloth. The ability to be injection molded and its lightweight gives plastic a cost advantage in many appliances. Next polymer is ABS, Acrylonitrile Butadiene Styrene. ABS is a two-phase system consisting of rubber in continuous polymer glassy matrix. The structure of ABS matrix is similar to ethylene, C to H4, CH instead of H atom, cyanide atom is present N times, and CH instead of H atom, benzene ring is present. The rubber is styrene butadiene and the glassy matrix is styrene acrylonitrile. ABS is an important thermoplastic for the manufacture of consumer goods. For example, telephones are injection molded from ABS. Almost everyone has dropped receiver, but it will not break because it possesses high strength, stiffness and toughness. Properties of ABS. ABS possesses outstanding strength and toughness. It has high impact strength, rigidity and hardness at high temperatures. In addition to fabrication by extrusion and injection molding, ABS can be cold formed, a technique typical to metal fabrication. Other polymers cannot be subjected to such type of metal cold forming. It possesses good dimensional stability and the mode of failure is ductile. ABS can be easily decorated by painting, vacuum metallizing and electroplating. ABS possesses good electrical properties and it is flammable. ABS have high temperature resistance and better solvent resistance than polystyrenes. Applications of ABS. It has found applications in the manufacture of helmets, suitcases, pump impellers, refrigerator doors, computer housings, tubes, pipes, etc. ABS has found applications include telephones, refrigerator linings, lawn and garden equipments, toys, highway safety devices and tool handles. The next polymer is PI, polyimides. Polyimides are made by polycondensation of aromatic dianhydrides and aromatic amines. The structure is CO, COOH, benzene ring, CO, COOH, NH, benzene ring, O, benzene ring, NH, N times. The first step in preparation of polyimides is a preparation of polygamic acid, which is converted to polyimide by further condensation. Properties of polyimides. PI can withstand temperatures up to 425 degrees Celsius for short time exposures without undergoing any deformation. PI materials are available as films and as lubricated solid parts. Polyimides retain unstable properties at 300 degrees Celsius for months and 400 degrees Celsius for few hours and withstand exposures of few minutes for temperatures over 500 degrees Celsius, which is similar to metals. Applications of polyimides. As it has to withstand very high temperatures up to 425 degrees Celsius for short time exposures, the polymer finds applications as surface coatings in supersonic aircraft. PI find application in electrical industry as insulation coatings of electromagnetic wirings. The next thermoplastic polymer is PAI, polyamide, imide. PAI consists of alternative amide and imide groups of elements. The structure is R, NH, C double bond O, benzene ring C double bond O, N and C double bond O, N times. This polymer is formed by condensation polymerization between trimellitic anhydride and diamine. PAI is the only plastic that can be heat treated similar to the metals. Other polymers cannot be heat treated, their properties cannot be improved by heat treatment processes. Heat treating this polymer for 1 to 6 days at about 250 degrees Celsius can double the tensile strength and elongation. In heat treatment process, phase change will not occur like that for metals. Instead, additional polymerization, chain lengthening will occur. This polymer has a higher strength and high maximum operating temperatures. Polyamide image has a high impact strength comparable to that of other plastics. Water absorption is also very less. PAI are expensive. They are lower in cost than the polyimides, but its cost is very high compared to other commodity plastics. Injection molding of these plastics is very good. Applications of PAI. Some components of automobile engines are made of PAI in order to withstand high temperature. Valves made from PAI replace bronze castings in hot water plumbing systems. Next polymer is PPO, Polyphenylene oxide. PPO is most useful as it blends with polystyrene. The structure is benzene ring CH3O CH3 N times. PPO is a tough temperature resistant engineering plastics but difficult to process. The blend is easier to process than polystyrene and higher in heat resistance and toughness than polystyrene. Properties of polyphenylene oxide PPO have excellent dimensional stability at elevated temperatures, good electrical properties and good resistance to aqueous environments. Water absorption is exceptionally low. This polymer has strength similar to ABS plastics. PPO is very expensive. Applications include making of appliances and computer housings. The next polymer is polyphenylene sulfide PPS. PPS is similar to PPO but it does not have methyl substitutes in the benzene ring. The simple diagrammatic representation is benzene ring with S N times. PPS is made by polymerization between dichlorobenzene and sodium sulfide. Properties of PPS. PPS has good property retention over wide temperature ranges. PPS is chemically resistant to most acids and alkalis. PPS is highly crystalline, so it possesses excellent mechanical properties. Applications of PPS. PPS finds use in manufacture of submersible, centrifugal, vane and gear type pumps, bearings, cams, valves, etc. PPS is used to make computer components like connectors, coil films and bobbins. Thermostats are partly made by PPS which gives good electrical and heat resistance. Thank you.